So let's talk about sequences. So I'm going to start to think about how we take collections of data of various types, say scalar types or more complicated, and organize them into collections, into groups, based on however we please. We want to design something like a container that has a set of data that we may be interested in. We're going to look at some different ways that we can conveniently store, organize, manipulate those sets of data in one-dimensional containers called sequences. So the common ones that we'll mostly work with, one of them we've already used, which is actually the string. So the string is actually not a scalar type. The string is actually a sequence of individual characters. In more complicated and more general examples, we have most typically lists and tuples. We'll go through both of those today. What is a list? What is a tuple? To just start, I've got an example here for these two sequence types. We want to say take a set of integers and put them in what's called a list. We just write out all of the different elements that we'd like in our list, separated by commas, and then enclosed in a pair of brackets. Now what that actually constructs we'll go through, but to start, you can build a list. My list equals, and then say 1, 2, 3. Print the type of my list, and let's see, Python tells me that my list is a list. And for tuples, it's quite similar. Tuples are specified in the same way, except they're enclosed in parentheses. I print the type of the variable my tuple specified like that, I get a tuple. Now, like the types that we've already worked with, there are specific operations that are defined according to these different types of sequences. We've already seen this example of when we add two strings. We found that two strings, when added together, just end up getting merged together, where one gets added on to the end of another. There are additional methods that are defined that are specific to sequences. The first of which is to just say get what's called the length of a sequence, in that the length of any sequence is the number of elements in that sequence. In the case of all of the sequences, the function for the length of a sequence is just len. And when I pass any sequence to the function len, it will tell me how many elements are in it. I see there's a question about the difference between tuples and lists. We will get into that. And there are some very specific ones. So it's a great question. In some ways, they're very similar. In other ways, they are quite different. Both of which, though, are one-dimensional. And so when I say declare some variable my list equals the integers 1, 2, and 3 separated by commas and in brackets, and then I print the function len of my list. So we're going to calculate the length of my list. Just call it my len, and then print it. I get 3. That's the number of elements in my list. Now I'll note here that it's possible to also define empty lists. So a list that doesn't necessarily have anything in it And that can be done by just having an empty bracket or set of brackets. So if my list equals, and then just a set of brackets, that's perfectly valid. And when I calculate the length of my empty list, I get a length equal to 0. Now that's also applicable for both tuples and strings. So in the case of strings, when I say calculate the length of some string, get a value of 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, including the space. Now, there are comparison operators that are also defined for certain sequences, and those are particular by the type of sequence. We'll go through those a little bit more here in a little bit, but more notions of having the same, say, specification of an operator, but actually meaning something different depending on the type. In the case of the strings, for len, for example, that calculates the number of characters in a string. For lists and tuples, it's the number of elements. Now, all of the sequences have a set of operators to do what's called slicing. And slicing is a way of getting particular elements in a sequence. Now, in general, we can access individual elements of a sequence by using what's called indexing. So for example, if we create some list that's my list of integers 1, 2, and 3, I want to get a particular element from a list. I can access it by index as follows. I want to get, say, the first element of my list. I can index to it using a bracket on the name of my list. So my list and a bracket, and then the index of the element that I would like to have or access, where the first element has an index of 0. So in this case, for this example, my list has values of 1, 2, and 3, and to get the value of 1 would be an index of 0. To get the value of 2 would be an index of 1. To get a value of 3, index of 2. And slicing is a way of doing this accessing of elements within a sequence, but more than one at a time. So something like a subset. And this looks like this. So let's switch over to working with strings. Strings are also sequences. So let's have some string, we'll just call it S, and just equals a bunch of nonsense. B, C, D, E, F, G, H. Just going to list some of the first letters of the alphabet, and we can do these slicing operations to get certain subsets or like groups of elements within our sequence using the following operations. So when we were getting individual elements, we would say my car equals, and then S of 0. S of 0 gets the very first element of this sequence. In this case is A. Now, like when using the range function, you can do something similar, but inside this indexing operation where we can specify the first index of a slice. In this case, I'm going to start with 3. And I want to get every element up to an index of 6. So 3 is my starting value, and every index integer-wise up to but not equal to 6. So here I get index of 3, 4, and 5, but not 6. And like when we worked with the range function, we can also specify the amount that this index iteration is increased by at every iteration, where the default value is equal to 1. So without specifying a third argument here, this will do 3, 4, and 5. Whereas if we say from 3 to 6, increasing at every iteration by a value of 2, this will do 3, and then 5, and then stop. So index 0, 1, 2, 3, then increase by 2, 5, and when increasing by 2 takes me past my stopping value, and so the slice stops. Now there are a couple of sort of shorthand operations defined here. So if, for example, I just enter nothing in between these colon separators, this is the same as copying the values of S into a new variable, my car. And if one would like to, say, iterate backwards, beginning with the end, and then moving all the way to the beginning, one can specify nothing between, or nothing as the first two operators, and then for the step, the third argument, just enter a value of -1. You see, this is now printing my original string backwards. See, the question is 2 colons or 1 the same thing? The answer is yes. So to make a copy of a sequence, whether it be a string, a list, or a tuple, you can either just enter 1 colon or 2. So this is to say, when entering 1 colon or 2, this is to say use the default values of each of these arguments. And in this case, the default values are 0 for start, a stop equaling the last character of the sequence index plus 1, and then a step equal to 1. So those can be used interchangeably. And then when iterating in the negative direction, one can also specify starting and stopping conditions, excuse me, where the starting condition is greater than the stopping condition, which is necessary because I'm iterating in the negative direction, as specified by negative step value. So this will start at an index equal to 4, 0, 1, 2, 3, 4, and then decrease by 2 steps, and then try decreasing another 2 steps, but that is equal to our less than our stopping condition, and so we get EC. So these operations are also true for working with other sequences. I would say it may be a little strange for some, this notion of, say, indexing negatively. So in general, Python will wrap a negative index back into a sequence starting at the end or the length index of a sequence. So if, say, doing s equals 0, s with an index of 0, index of 1, s index 2, this is doing A, B, and C. But then one can also do the exact same thing going in the negative direction, s with an index of -1, -2, -3. -1 will be the last element in the sequence. The index of -2 will be the element before that, -3, the one before that, and so on and so forth. I'm going to skip this example and leave this to everyone. I'll provide some code for what actually does this. I'd like to continue on for now so we don't get behind again. So this will be made available after today's lecture, and of course I'll be available to answer any questions for how to get through this. But I'd like to move on, check in with everyone, make sure we're all up to speed. All right, give it another minute, see a few people need a little bit more time. All right, let's continue. This is a good exercise. I think we can do this one probably pretty quickly. So let's do this one together. So in this exercise, we're going to start with a string. We can work with whatever word you like. We could just work with the first few letters of the alphabet. And the exercise is to create a new string that is the original string in reverse. So let's do this together. And let's do it like this. Let's practice our for loop. So let's do an iteration over the length of our original string, which in my case I've just called S. Let's say for in and range. So we'll have an iterator iterating over some range, and let's just say from 0 to the length of S. Remember, if we don't specify multiple arguments, then the starting value of our iterator will be 0, and it'll iterate up to but not equal to the length of S. And let's enter a colon. And now let's go back up and let's declare a new string, and we'll call it new S, and let's just start by creating an empty string. And the creative way that we're going to do this, we're going to practice a few operations. Let's do at every iteration, we're going to add to new s. Remember, if we take two strings and add them, it'll join both strings together. Let's say new s equals new s plus, and then something from s, our original string. And the thing that we'd like to get is beginning at the end of our original string. Get H, then get G, in my case, get F, then E, so on and so forth. We're going to do that using negative indexing. Now recall that an index of -1 refers to the last element of a sequence, and then the one before that, and so on and so forth. And so what we can do is, beginning at -1, for n beginning at 0, we can just do -1 minus n. So n equals 0, this will be -1. When n equals 1, this will be equal to -2, then -3, so on and so forth. And this is just being added over and over to our second variable, new s. So let's run that and let's print it at the end. And there you go. Now I see there's at least one comment in the chat about a one-line solution to this problem. Totally acceptable. And most often, not most often, I don't want to encourage any particular behavior, but very often briefer code can be better code. So lots of solutions to do this. Just a little bit of practice here with some of our content for today. So I'll have another version of this posted online as well for your reference. Let's go ahead and move on from that. Now again, these operations also work for generating lists. From lists, you can also print these slices directly. So for example, the list type has functionality built in to be able to print them directly. So you'll notice when we declare some list from the integers from 1 to 4 and then print it directly, we'll just get a string of the list elements printed directly. And it's also possible to say print slices of those lists as well, or of sequences in general. You can also do assignment. So it's possible to say assign to subsets within sequences or subsequences, however you want to think about it, using slicing as well. So if, for example, notice here I have my variable myList. That's a list from 1 to 4, the integers from 1 to 4, and I'm just doing a slice to index the second and third elements. And you'll notice that then if I do something like myList, and then slicing from 1 to 3, I can actually declare that as a list, something like within a list. Now, it's not a list within a list. What it is using this slicing to create something like a temporary sequence consisting of all of the elements that I've accessed using my slicing operator, and then assigning to each of those values in that sequence the corresponding values in this list that I've declared here on the right-hand side of my assignment operator. So this is accessing elements 1 and 2, and then saying assign to those elements 1 and 2, assign the new values of, in this case, 5 and 6. We print all of this all at once. You see, I start with my initial list of the integers 1 through 4, doing some slicing just to get the first or the second and third elements, which are 2 and 3. And then by assignment, using the slicing operator, actually replacing the values of the second and third elements of the sequence and setting them to 5 and 6. Just as a quick note, we worked with the range function in the previous module. It's also it's also possible to use the range function to generate lists quickly. In this case, if I wanted to instead generate this list of 1 through 4 using range, I could have also done something like passing to the range function the starting and stopping arguments of 1 through 5 that iterates from 1 up to but not equal to 5, and then taking that and passing it to the list constructor. The list constructor meaning the name of lists as a Python type is just list. And when I pass the return value from range to list, it will create a list consisting of all of the elements that were returned by range. In this case, 1 through 4, or 1 through 8, if I change the arguments from 1 to 9. So just as a quick aside there. So an interesting distinction between our strings and lists that we've worked with so far, and we'll find a distinction like this for tuples as well, is that elements of string sequences can't be changed. When you declare a string and then try to change, say, one of the characters in a string using indexing or slicing, you'll find that you'll get some kind of error. And that is because the string is called immutable, in that once it's been declared, the elements that it consists of cannot be changed. Say S equals ASFD and then S of 1. So indexing to access the character S in ASDF and try to change that to B, and I get an error. Specifically a type error that says that the string does not support item assignment. Now, if I try to do the same with the list, obviously, as we've seen, this will work. My list and try to index to the second value and change it to 4. No problem, because lists are changeable. Their elements can be changed, or they are what's called mutable. Whereas strings and also tuples, which we haven't really worked with yet, tuples are both immutable in that once a string or a tuple has been declared and the values have been assigned, the underlying elements of those sequences cannot be changed. You can create a new variable with new data, but you cannot assign new values to individual sequences that are immutable. Now, I've neglected tuples mostly because most of the operations on tuples, which again were declared using parentheses instead of brackets like in lists, most of the functionality of tuples is the same as lists. Most of the operations that we see will be the same for lists and tuples. The only major difference being that tuples are an immutable type of, or immutable version of lists, or vice versa, in that you cannot modify underlying elements of tuples. One cool thing about all of the sequences list tuples and strings in this case is that they can be very easily iterated over in for loops. So up until now, we've been doing things like for in range of 5, and this will go from 0 to 4, every integer. Now if I have a list or a tuple or a string, let's do a string. Say my str equals ASDF. Now what I can do is actually create an iterator in a for loop that instead of iterating over some range of integers, instead I can actually iterate directly over every element of the sequence. In this case, for a string, I can say for, let's say, some iterator named s, for s in, and then just pass the name of the sequence. For s in my str, and then just print s. And you'll see here that this is iterating over every element of this sequence, the string that's been declared here. We can do the exact same for lists and tuples. So let's say my tuple equals, and as Jim pointed out in the chat, you can declare tuples with or without parentheses. I prefer and recommend the parentheses just to make things explicit and clear. Say my tuple equals 1, 3, and 5, and then say for t in my tuple. And just print t. You see that in this branch, every element of the sequence that I've passed is being accessed and is available to do whatever we please in this branch. I'm going to check in with everyone, make sure everyone is doing well. Make sure we haven't lost anyone yet. See, at least one person needs more time. Give this a second. All right. Let's continue. Got a couple of examples here included here for your reference and your review. Those will be available with the slides after today. This is a nice example here of how I think to make code more intuitive to work with. This is one of the most invaluable things about Python, in my opinion, is that it's very close to something like almost like how you would actually describe operations with, in common language. So you'll notice here, as I pointed out, that it's possible to construct an iterator to index over, say, all of the elements in a sequence. But one of the most powerful things about these just very basic sequence types is that then you can start to construct code that works directly with the elements and in excuse me, in something like a comprehensible way. So not actually going through and accessing each individual element of the underlying data, but instead iterating over the data in the sequence itself. Excuse me. Now, of course, it's important to point out here that for the sequences are order specific. So the order in which the data is input into the container or the sequence when constructing it is then the corresponding order by which it's organized when doing things like iterations over it. All right, so maybe give everyone a couple of minutes to kind of work through this. So this is an exercise of taking two strings, excuse me, taking two strings and printing all of the characters that can be found in both strings. And so this is possible by doing something as simple as what's shown here on the right. This is simply just taking, say, S1 equals some gibberish, and S2 another string equals some more gibberish, and just iterating over both strings. Say for I in S1, I will be iterating every element of my string S1, and then for J in S2, iterating over every element in the second string for every iteration over the elements of the first string. And then just ask, is I equal to J? This operation, this comparison is defined for strings. Are two strings the same? And if they are, just print it. Run this, and in my two gibberish strings, this will go through and tell me all of the characters that are in both S1 and S2. There's a good question in the chat from AJ about if elements in a tuple need to be numbers. We'll go through this here in a second. We can come back to this exercise. Yeah, AJ, excellent question. So one of the main differences between strings and the other two sequences is that both lists and tuples, well, you can try this experiment on your own along with me. Let's say my list equals, in every example we've done so far for either lists or tuples, my tuple, we've got just an empty list and an empty tuple. We've been doing things like a list consisting of integers. Can we also do, say, a list of strings? Or say a tuple of a float and a string and an integer. You see, when I run this, I get no errors, and that's because for both tuples and lists, the data contained by both of these sequences can be heterogeneous. It's possible to put not only whatever type you please into one of these sequences, but it's also possible to put whatever combination of types you want into one of these sequences. So this not only supports doing heterogeneous data with, say, combinations of strings, floats, ints. It's also possible to do that with other sequences, like shown here with the strings. It's also possible to do things like make lists of lists and so on and so forth, as well as more complex data types that you or someone else has designed. So tuples add, tuples and lists both add like strings. So we saw this in module 1. If we had 2 strings, then we added them, then the 2 strings that are being added would just be joined together, and that would be the result that's, in this case, being assigned to some new variable S3. S3 being S1 plus S2, where S1 and S2 are A and B, respectively. Same is true for tuples and for lists. So we can try this out. Say A is equal to a list of 1, 2, and 3.0. And B is equal to, I don't know, 2.0 and some string A. What is, say, the result of A plus B? You'll see here that for A and then B, here's the elements of B, and here are the elements of A. This is the result of adding 2 lists, is that the elements of one and the elements of another are added together, and that's the result of this operation. The same is true for tuples, and this can be very quickly converted into a test like that. But for tuples, just by replacing the brackets with parentheses, you see now got the same data, but instead of being in a list, it's in a tuple. We'll note here that the addition operator here, I feel strongly implies that there is also a corresponding minus or subtraction operator, something like removing elements B from elements A or something like that. You'll find that this is not the case, that for both lists and tuples, for the sequences, this subtraction operator is not defined for those sequence types. Of course, as we'll go over later today, you can design your own type of list that does support that operation. But the list, tuples, and strings that we'll work with that are built into Python do not support this. Now there's a bit of details here that I've more left in for your reference than really wanting to dive into today. But tuples have, for example, some interesting ways that they can be used to be able to, say, do substitutions or say switching values in pairs that have been passed for different operations. And in particular, what I wanted you to see here is how to declare something as a tuple as opposed to getting, say, a scalar value back with some syntax that you thought might have generated a tuple. So in general, I think it's clear that to say declare a list with one element, one can just take some value for an element and enclose it in a bracket. Now, when you try this for a tuple and just say, for example, my tuple equals 1 in parentheses, let's print the type of this variable that's created, and you'll notice here that when I just say parentheses 1 to try to create a tuple with one element that has the integer 1, I actually get back an int. So a tuple is not created by this. And now let's try this with also with my list. We can print the type of, and you see that this actually works for the list. So in the case of tuples, for creating tuples that have a single element, what's necessary is to also include comma. There's nothing trailing that comma except the remaining parenthesis of the parentheses. But this tells Python that this is a tuple and it has one element, as opposed to being an integer. And you notice that the same is not true for creating an empty tuple. So if I put a comma in parentheses, I end up getting an error there. In that case, you can do something like actually using the name of the type, which is tuple, all lowercase, and empty parentheses. That creates an empty tuple. All right, I'd like to go back and how much time do we have? We're on until 1:45. All right, let's continue on and we'll come back to this exercise if we have time. Because I'd like to reserve a little bit of time on some of the operations that we have at our disposal that make lists and tuples and strings a lot more powerful and a lot more useful for everyday applications, in our case, in modeling cells. And we've seen this. Now, let's try this. So we had the case of adding two lists, and what we found was that we could combine two lists into a resulting list by just using the addition operator. So if I have some lists A and B, and I just put some random data into it, and I say C equals A plus B, that created a new list that was the combination of the data in both A and B. Now, lists in particular, they have additional methods defined on them to be able to do operations on the lists themselves. So for example, in this case, shown here, we want to do something like this addition operation, but instead just add the data from B to A, not while creating a new list, but actually just adding, or what's called appending, the list data of B into A. Instead, we can do something like using this method append on this list A, and we can do that as follows. So a list has methods that can be accessed and used by first typing a period after the name of our list. So if A is a list, I can use methods defined on that list by using a period. And you'll notice on my screen, I get a lot of functions that pop up to pick from. In this case, I'm going to use append. And when I say a.append, this is a function, and we can pass something to it. The thing we're going to pass is, say, the first element of B. And we would do that with B, and then use an index of 0. So A dot append, and then pass the first element of B. We find that when we print A after this operation, now A has the first element of B. And of course, what's passed into this append function is not reserved to data that's in lists, but can just be arbitrary data. So A dot append of 0 will add a 0 into the list here called A. Good question. How can we see the list of operations available for an object in Jupyter? Unless there's some upgrade that I know of or I've not heard of, I don't think you can. I don't work a lot with Jupyter notebooks, so James or Giuliano or Jim, please correct me if I'm wrong, but this functionality of generating these function suggestions is not something that Jupyter notebooks will do. Is that correct?
I think you should be able to do a dir on the function.
Yes.
And a dir on the object.
Yeah, so there's a way, there's a built-in way in Python to be able to see everything that's defined for a particular variable. This may be one of your best friends. I know it's one of James' favorite functions in Python, if not his favorite, and that is dir, as he suggested. So when you pass any variable to the function dir and then print that, you find this list of names of all of the things defined for that variable. And most of them may look fairly incomprehensible, not familiar at all, but you'll notice that one of them in that list for my list variable was the name of the function append. And actually, the names of all of the things that were suggested that pop up in my IDE, those are all available by printing dir of A. So that's the fast and dirty way to get that information. Another excellent question in the chat, reading my mind, which is how do you append all the elements? Presumably all of the elements in a list that's been passed to something like an append function. And that actually takes us to our next slide, which is one of the next most commonly used functions for defined for lists, which is called extend. And extend, yes, as Giuliano just answered in the chat, extend is like append, except extend will append everything passed to it from that's in a sequence. What I mean is, we say a dot extend and then pass the sequence, here the list, B, and then print A. And find that all of the elements of B have been appended to A.
DJ, show us what happens if you do A dot append B.
Excellent suggestion, Jim. And maybe this is a thought experiment to pose to everyone to think about for 10 seconds. If I do say A dot append, so append to A, but instead of passing an element of B, I pass B, the list, what goes into A? And as mentioned earlier, both lists and tuples support heterogeneous data, including other sequences. And so when I say A dot append and pass B, the list B gets added to the data of the list A. So a list within a list. Excellent suggestion, Jim. Thank you.
Are you going to cover VStack and HStack?
If we get to it a little bit later.
You might just mention that those are the standard tools for doing.
Okay. Excuse me. Now, there are a lot of operations that are defined for lists and tuples, and again, as kind of demonstrated by the number of suggested functions that pop up for in my IDE when doing operations on these lists. And so it's certainly not possible to go through all of these. We'll hit a point today where you know, it was sort of like highlight maybe our favorite or the most commonly used features of these different types like tuples and lists and strings. And then, you know, that will almost certainly consist of a limited subset of all of the possible functionality that's defined for that type, or later for functions and modules and all sorts of complicated things. And so probably starting now, there'll just be the running assumption that what's described about these, in this case, these sequence types, and for everything else, that what I'm telling you about is a very small fraction of what actually exists. And so in this case, we've talked a little bit about adding elements or appending elements to sequences. We can do the same for lists, not tuples, because tuples are immutable. But for lists, we can do things like remove specific elements. So if, for example, I have my list A that has an int 1 and a string A, so heterogeneous data that has a sequence in it, and I say A dot remove. If I pass, say, 1, the int 1, and then print A, I'll find that the element 1 is no longer in A. Remove removes the value passed to it from the list on which remove was called. Now, if we try to pass a value that's not in the list, we'll get an error. In this case, a value error. And in my case, I'm given an explicit message that what I passed is not in the list. That's nice. On the other hand, there's also a very commonly used method called pop. Pop is like value or remove, except that instead of removing an element by value, I'm going to remove it by index. We can do A bracket 0 to get 1 by the index 0. We can do A dot remove of 1 to remove 1 from A. Or we can use A dot pop and give the index of 0. And we find again that 1 has been removed. If we pass an index that's not defined for this list, meaning that the index is greater than or equal to the length of A, get what's called an index error. It says pop index out of range. Tried to pop an element that wasn't there. And then there's, of course, a built-in method that's not as commonly used for these types of operations, but there's a way to delete things directly in Python, not things as in your hard drive, but as in variables that have been stored in memory, and that's just called del. And in this case, when I say del a of 0, this is delete the first element of a. And yeah, now you see that the first element of a is automatically removed by deleting it. And if I say del a and then try to print it, you see a is not defined. It's not defined at line 5 because I deleted it altogether at line 4. Okay, there's a lot of operations defined here. And again, this is a question in the chat. Can you pop multiple elements? Multiple elements in the case of doing something like that, perhaps? Okay. Yeah, good question. So slicing operations like this are not defined for pop. And of course, it's possible to do something like slicing like this. Notice here, I've done a slicing operation to get both the first and second elements of A and then delete them. And I find that when I print A, it's empty. But for pop, no. Yeah, exactly. Good question. All right, I think we're coming up on lunchtime. There are a lot of, again, operations defined for all of these. So I'm actually inclined to leave it at that. And if anything, share the link to the Python library documentation to be able to quickly find where the documentation on all of these methods, which I have not done justice for. I mean, you can see there are lots of functions like reverse to reverse the order in memory and so on and so forth. I don't feel that it's particularly important for us to master a strong knowledge of all of the things that are defined for these types, but rather to have a strong sense of what can be done and a working knowledge of where to find the information on the details. So we've got a questionnaire going. I'm going to call it the end of this module, and again, make these slides available. There are a few exercises and some more details on some of the particularities of sequences. Again, very much a subset of the functionality that is well described in the Python documentation itself, which I'd be happy to help you sift through and look for information on. And then, of course, there's an exercise here that's included at the end of the slides. I will also provide the scripts, the solutions for all of these exercises, just something that how I designed all of my solutions for the exercises. Those will be available as well. So don't feel like we're missing out on content for the sake of making lunch.